All right, so today we're doing lesson 5.3. This one's kind of tough if you're absent today. They're called proofs. A lot of explanation, justifying our reasoning. We can do what because of why. That's kind of what these are today. So, have some vocab words here. It says detectives. A police detective uses analytical thinking to solve crimes. Inductive reasoning is the process of making a conjecture or an observation after observing several examples, or he makes a hypothesis or a hunch, or he uses his evidence. Unlike inductive reasoning, deductive reasoning uses facts, rules, definitions, or laws to make conjectures, to make statements in given situations. So we're going to label these situations as whether you think it's inductive or deductive, using facts or just observing. So every time Bill watches his favorite team on television, the team loses. So he decides not to watch a team play on TV. So is that fact? No. That's just based on his observation, so it'd be inductive. All triangles have 3 sides and 3 angles. Mariah has a figure with 3 sides and 3 angles, therefore it must be a triangle. Well, that's fact, deductive. In order to play sports, you need to have a B average. Fact. Simon has a B average, so he concludes that he can play sports. That's a fact. After performing a science experiment, Liddell concluded that only 80% of tomato seeds would grow into plants. So did she use a fact? No, she just watched her plant grow. Okay, so on this next slide, these are not vocab words, but they're things that might help us on our coming up homework that we should be familiar with. Adding 2 segments together on a line is called segment addition. Postulate, so that's the definition or the vocab word for that. Blank states that dividing both sides of an equation by a non-zero number doesn't affect the equation. That's the division equality property. We'll be able to abbreviate these in our work. Replacing one value with another, that's called substitution. We've seen that before, it's a plug and chug. States that if the number is added, so this is the addition property of equality, states that if the same number is subtracted, so the subtraction property of equality, if 2 angles are adjacent, their sum is the entire angle. Well, that's called angle addition. A linear pair of angles is a pair of adjacent angles formed by intersecting lines. So those are some things we might use to help us with our proofs coming up. Here's some more vocab words. So it says a proof is a logical statement where each statement is justified by a reason. A paragraph proof, also called an informal proof, involves writing a paragraph to explain why a conjecture is true. In example 1 below, you'll use the algebraic property of substitution and the geometric relationship between vertical angles. So we see some things here. So the diamondback rattlesnake has a diamond pattern on its back. An enlargement of the skin is shown. If the measure of angle 1 equals the measure of angle 4, so 1 and 4 are equal, write a paragraph proof to show that the measure of angle 2 equals the measure of 3. So these 2 are equal. Well, what do we know about those? They're not on parallel lines, that doesn't help us. But 1 is vertical to 2, and 4 is vertical to 3. So if we can say that 1 equals a 2 and 4 equals 3, then because 1 equals 4, 2 must equal 3. So we'll kind of write that out in our words here. So geometric proof of vertical angles. Since angle 1 and angle 2 are vertical, comma, the measure of angle 1 equals the measure of angle 2. Since the measure of angle 1, since, you know what, let's just say and likewise for angle 3 and angle 4. likewise, angle 3, the measure of angle 3 is equal to the measure of angle 4. By substitution, we'll take out, by substitution, measure of angle 2 equals, so taking 1 out, putting 2 in, 4 out, putting 3 in. 3, measure of angle 2 equals measure of angle 3, since we were given measure of angle 1 equals the measure of angle 4. So, since we've proved it right here, a lot of times little fancy proofs end with a little square filled in, just fancy. So that's a paragraph proof. We basically just write a paragraph on why we can do what we do. I like 2-column proofs, which are coming up. And that's where we'll focus our homework. So there's that segment notation, little hint here. It says AR with a line over it. It's supposed to have a line over it. It's the measure of line of segment AR. Nope, I guess not. No line. Just AR is read as the measure of line segment AR. So it's just talking about the line segment. Refer to the diagram shown. AR equals CR. So we know that this part on the top is equal to this part on the bottom. So I'm just going to write a little line here. And DR, we don't know that those two are equal, so we're just going to put 2 lines, equals BR. So top and top is equal to bottom and bottom. Write a paragraph proof to show that AR plus DR, so the top, is equal to the bottom plus the bottom. So we are given that AR equals CR, fill in the blanks, and DR equals BR. Prove that AR plus DR equals CR plus BR. So we're just going to try and fill in the blanks as they say. So we know that AR equals CR and DR equals BR. So we know that top equals bottom. So it says AR plus DR equals CR plus DR by the addition property of equality. So AR here plus DR is equal to CR plus DR. So that's that line. Addition. So AR, so now they're taking out AR plus DR equals CR plus BR because DR and BR are equal, so we can take one out and put the other one in. That's called substitution. This isn't necessarily the way I would write this paragraph proof, but it's one way. Let's look at this one. I like these ones better. 2-column proofs, and I like the ones that have math involved, actually. A 2-column proof or formal proof contains statements and reasons organized in 2 columns. Once a statement or conjecture has been proven, it's called a theorem. So a statement or conjecture has been proven, it's called a theorem. And it can be used as reasons to justify statements in other proofs. So on slide 2, we talked about postulates. That's like a theorem. It's been proven over and over again. The statements for a 2-column proof show that if the measure of angle y, so this one, equals the measure of angle z, then x equals 100 are given below. Complete the proof by providing the reasons. So there, the first thing that we're always going to see is the stuff they give us. So they're saying that these 2 angles are equal, that this one is equal to 2x minus 90, and this one's equal to 2x or x plus 10. Your first reason, reason A, will always be given. Your first reason will always be given. So that's free points. You know the first one is always going to be given. Now what we can say is 2x minus 90 equals x plus 10. So they just take this out, put this in. Take this out, put this in. What's that called? Substitution. So B. Substitution. C. Well, looks like they got this x to be moved over here. They used subtraction. So they just subtracted this x. And then they get the 90 on the other side by adding or addition. And then it's done. Here's our proof. X equals 100, that's why. So I like those ones better. Let's try one over here, slide 2 or slide 6. Write a 2-column proof to show that if 2 angles are vertical angles, then they have the same measure. It says lines M and N intersect. Angle 1 and angle 3 are vertical angles. So we're going to have to prove that angle 1 equals angle 3. We can't just say they're vertical, so they're equal. We have to prove vertical. These ones are the hardest thing to do, is to prove definitions, I think. But what are we given? So statement 1 is that M and N, lines M and N intersect, and angle 1 and angle 3 are vertical angles. Our first statement will always be given. Our second statement, so we know that these two are vertical. Well, what do we know about the other angles that we have to work with? We have to prove that angle 1 equals angle 3. So maybe we could say something about how angle 1 and angle 2, these are on a line. What do they have to add up to? 180. So we said angle 1 plus angle 2 equals 180. Well, we need to also get 3 in there somehow. So 3 plus 4. Angle 3 plus angle 2 plus angle 3 equals 180. That way we're just using that angle 3. Angle 2 plus angle 3 equals 180. So now we know that that would be called a linear pair. That was on slide 2. Statement 3. Well, if these are both equal to 180, then we can set them equal to each other. So angle 1 plus angle 2 equals angle 2 plus angle 3. And that would be substitution. When in doubt, substitute it out. Now, we can, to get angle 1 to equal to angle 3, we have an angle 2 on both sides. So we could subtract angle 2 from this side, subtract angle 2 from that side. So that's, oops. So we'd be left with angle 1 equals angle 3. Throw the n's in front, because that's really long to prove. And how do we do that? That was by subtraction. These take a little while to get to practice. Most of ours will be like this. The algebra one. Or like this one. Slide 7, number 2. It says, refer to the figure above, complete the two-column proof to show that if EG equals 3x minus 1, I like to label this, so this is supposed to be a G up here. So if EG equals 3x minus 1, and ED, can't read, equals 2x plus 4, and EG equals ED, then x equals 5. So first thing here, we're given that information, so the reason is given. Well, what have we done here? We've taken out, since EG equals ED, we've replaced these and put them in their spots. That's called substitution. Letter C looks like we subtracted 2x from this side, so that will be called subtraction. And to get the x by itself, we added 1, so addition. Okay, this one says, use the figure to complete the paragraph proof. So angle 1 equals angle 2. Those two are equal. And angle 1 and angle 2 are supplementary, which means they equal 180. We need to prove that angle 1 and angle 2 are right angles. So the measure of angle 1 plus the measure of angle 2 equals 180 degrees, since they are supplementary angles. Since the measure of angle 1 equals the measure of angle 2, then technically you could say the measure of angle 1 plus the measure of angle 1 equals 180 by substitution. We could just take, since 2 is equal to 1, replace a 2 with the 1. Solving the equation, you end up with, so the equation they're thinking is like 2 measure of angle 1 equals 180. So let's divide by 2. So you get the measure of angle 1 equals 90. Since the measure of angle 1 equals measure of angle 2, then the measure of angle 2 is also 90. Therefore, angle 1 and angle 2 are right angles. And there we have it. So have a great day. We're going to actually work on this skills worksheet together in class to do our best there.